Okay, so we just had a quick review of the imaginary numbers that you studied in algebra, and now we're gonna plot complex numbers in the complex plane. What is a complex plane? So here is would be your real axis, and here would be your imaginary axis. So suppose I want to plot 3 minus 2i. How do I do that? Well, this is your real part, right? And this is your imaginary part. So you have 1, 2, 3 for the real part, 3, negative 2i, negative 1, negative 2. So 3, negative 2, this is, we just plotted the complex number 3 minus 2i. Okay, so it's as simple as that. Go ahead, I want you to plot this point right here, 2 plus 5i. How would you plot that? So what would you do? Here's the real part and real axis. Here is the imaginary axis. I hope you got this is the real part and this is the imaginary part. So the real has 2, so we have 1, 2, here we go. And imaginary 5, 1, 2, 3, 4, 5. So 2, 5 right here. That is your we just plotted 2 plus 5i. Okay, so you can go on and plot other points as well. Let's do one more here. How would you plot that? So go ahead and stop the recording and you can go ahead and do this. Okay, so the real part is this one here, negative 3, and the imaginary part is negative 1i, right? There's a negative 1. So this is your point right here, negative 3 minus I. Okay, so let's see, the polar form of a complex number. Polar form of a complex number. Well, let's see. Here's your real axis, here your imaginary axis. And this is a point, or let's see. This is point right here would be what? X plus yi or a plus bi, right? And here's your theta. This is r. This one is y, same as here. This is x, right? And what do you have? X is equal, let me remind you what is cosine theta. Cosine theta is adjacent, x over hypotenuse, which is r. Remember, this is 90-degree angle. So that means you have what? X is equal to r cosine theta. And sine theta is what? Opposite over hypotenuse. So y over r. That means y is equal r sine theta. And if you recall, r square is equal x squared plus y squared. You may want to write as r is equal to square root of x squared plus y squared. Theta is the argument and r is the modulus. How do we write polar form of a complex number? What is the polar form of a complex number? Where we know that a complex number looks like this: z equal x plus yi, or a z equal a plus bi, doesn't matter. X is the real part and y is the imaginary part. How do I write this? Well, x is equal to r cosine theta, y is equal r sine theta, right? And I can factor out the r. We get r cosine theta plus sine theta. In an abbreviation, if we abbreviate it, what do we get? RCIS theta. RC, oh, there's a, we forgot the I here. I times y, I times y. So RCIS, that's an abbreviation of r cosine theta plus I sine theta. RCIS theta. So if you have r, you have theta, you can write it like this. These two are equivalent. The book mentions something in Euler's formula. RE to the I theta, if you write it like this, that's the same as r cosine theta plus I r sine theta. So this is the same as this, but this is in Euler's formula. Okay, so let's go ahead and use examples. So let's see. So write this in polar form. So write z equal 3i in polar form. So how do we do this? Well, z is really here. It doesn't have a real part, does it? So that's the same as 0 plus 3i. So x is equal to 0, right? And remember, we need r, don't we? Remember that r is square root of x squared plus y squared. We know x equals 0 and we know y equal to 3. So this is x, this is y. So r is square root of 0 squared plus 3 squared. That's the square root of 9, isn't it? Which is 3. So r is equal to 3. Okay? And now we need to find theta. How do we find theta? Remember, in order for us to write it in polar form, what is a polar form? Let me remind you, we just did this. Z equal r cosine theta plus I r sine theta, or an abbreviation, RCIS theta. And this is in Euler's formula, Euler's form. RE to the I theta. So we need r and we need theta in both cases. We already found r, we need to find theta. How do we find theta? Now remember, x is equal to 0, but also what is x is equal to? X is equal r cosine theta, isn't it? And that is equal to 0. We already know that r is 3, so r cannot be the one that's 0. Cosine theta must be equal to 0. Cosine what angle gives me equal to 0? Theta must be pi over 2. Okay, so we have r and we have theta. So in polar coordinates, z equal 0 plus 3i can be written as what? As z equal, let me write it down again, r cosine theta plus I sine theta. right? So here, r cosine theta plus I sine theta. We already know what is r. R is 3. Cosine theta is pi over 2 plus I sine theta, which is pi over 2. So this is in polar coordinates, or in abbreviation. What is that? R cis theta becomes what? R, which is 3, cis theta, which is pi over 2. How do we write it in Euler's? So remember, it's what? R e to the I theta. R is what? R is 3 e to the I theta. What is theta? Pi over 2. So 3 e to the pi over 2I. So let's go ahead. I want you to do another problems. So write this in polar form. Same question. Z equals square root of 3 plus I. Write it in polar form. Remember, Z is equal x plus yi. X plus yi. So go ahead, pause the video a little bit and try to see it. Try to do this by yourself. Go ahead. Okay, so let's see. This is x, so x is equal radical 3, and y, there's an invisible 1 here, y is equal to 1. Immediately we can find r. R is the square root of x squared plus y squared. Square root x squared is this one squared. X squared is equal to 3, remember. So this one would be 3 plus y squared, 1 squared is 1. So that's square root of 4, which means r must be equal to 2. So we got one thing here, r equal to 2. Now we can go ahead and find theta using x equal r cosine theta, or simply you could have seen it from here. Cosine theta is x over r, right? Cosine theta is x over r. We already have x, which is what? Radical 3. We already have for r, which is 2. Remember, this is a common angle, root 3 over 2. Cosine what? Equal root 3 over 2. You can, if you want to, do here cosine inverse root 3 over 2, but there's no need to. I think you know that cosine pi over 6 is root 3 over 2. So theta is root 3 over 2. So we have theta and we have r. So now we can write it in polar form. Again, what is polar form? Z equal r cosine theta plus I sine theta. R is what? We just found it to be what? 2. So 2 cosine theta is pi over 6 plus I sine pi over 6. Abbreviation, what does that give me? Z is equal R CIS, remember? So R is 2 CIS theta, which is pi over 6. How would we write it in Euler's? So R e to the I theta, R is 2 e to the I theta, so I times pi over 6, or 2 e to the pi over 6i. Okay? Now I want you to go ahead and convert to rectangular form. So I'll give you one that has polar form, and I want you to convert it to rectangular form. So z equals 4 cosine 11 pi over 6 plus I sine 11 pi over 6. 11. Okay, so remember our formula is what? Z equal R cosine theta plus I sine theta. So R must be 4 and theta must be what? 11 pi over 6. Okay, we don't need to go like this. All we had to do is go directly and evaluate this. What is z? Z is 4. What's cosine 11 pi over 6? 11 pi over 6 in the fourth quadrant. That's the same. Cosine 11 pi over 6 is equal to cosine the reference angle of pi over 6. Remember, the cosine in the fourth quadrant is positive, just like the one in the first quadrant. So cosine pi over 6 is rad 3 over 2. Plus I, what's sine 11 pi over 6? Sine 11 pi over 6 is going to be negative. The sign in the fourth quadrant is negative. So that's negative sine pi over 6. Sine pi over 6 is 1/2. So remember, I'll write it down here on the side again. Sine 11 pi over 6, this is a review, is equal to the negative sine, the reference angle of pi over 6. Again, why is it negative? Because it's in the fourth quadrant, and sine in the fourth quadrant is negative. Sine pi over 6 is 1/2, so it's negative 1/2, and there you have it. We can go ahead and distribute. Z equal 4 divided by 2 is 2 rad 3. 4 divided by 2 is 2, right? But you have a negative, so negative 2i. So 2 rad 3, negative 2i. We just written it in rectangular form.